Creating a graph of a function is a very easy way to help determine the domain and range as well. And there's a lot of other interesting and useful information that you can get from doing that as well. And basically, in this video, I wanted to review graphing terms such as intercepts and finding properties of the graph based on doing so. And I also wanted to show you how you can graph functions in your calculator as well to greatly alleviate this process. But basically, you could figure out a graph of a function by finding some of the coordinate pairs based on input and output in that relationship. And you could start off by making a table of values, much as you would do in basic algebra. Sorry, I need to zoom in on my tablet a little bit. And basically pick some random values for x and figure out, well, what would the value of f of x be at that particular location. So, and also when you're graphing like on paper or, in a typical math scenario, you're often graphing on a small little XY grid. And so if you're wondering, well, the domain is always a set of inputs, which goes on the x-axis. And the range is always a set of outputs, which typically go on the y-axis f of x. If you ever wondered, well, why do they go in those particular locations? There's not necessarily a good reason, but it's the standard way of doing it, and there's a lot. And most graphs are set up in such a way where it's kind of like causal axis is the x-axis, and the y value describes how it's changing cause and effect. But basically, if you're wondering what value should I pick for x, well, we can see right here that these are the values on our graph, so we could pick all the values between -6 and 6. And so that, or what maybe I'll do is I'll just start from -4 to 4 and use that as a starting grounds, because I'm not going to be able to fit much more beyond that. And if I want to determine, well, x is a set of inputs or the values of the domain, and my y values or my f of x values are going to be what is the output value based on that correspondence. And again, I have a formula for doing that. So it says that to find the value of f of x must be equal to the absolute value of x minus 1, then minus 2. And say I wanted to, let's start at 0, just because 0 is an easy number to calculate with. We can figure out f of 0 by plugging it in. And again, if I'm plugging in 0 here, I'm going to plug it in for all locations of x in the formula. So that would be the absolute value of 0 minus 1 minus 2. And again, the lines, I know I said that the lines mean such that. That's specifically in set notation in a singular line. It's actually a little bit of a longer line than the absolute value line, which one of the things that's annoying with math is a lot of times certain symbols mean the same thing in different contexts. Sorry, my dog let out a big sigh. I think he's tired of me talking because I've been doing this all day. But anyways, in this case, what I'd have is the absolute value of -1 minus 2. And recall that the absolute value, anything that, if the input number is negative, what it always turns it into is positive. The absolute value takes just, well, what's the absolute value of the number? It makes it positive, which would be 1 minus 2, and 1 minus 2 is, of course, -1. So after I completely do that calculation, I can figure out, well, input variable 0, output is -1, and that's going to be the range element corresponding to that. Or again, you could kind of imagine it as input-output arrows like the World Series example, but with the mathematical formula, you have numbers, and we have a numerical correspondence defined by a formula. I do apologize. I'm slurring a little bit. I am very tired, and I'm doing my best to enunciate and not fall asleep. And we could continue this process for the rest of these. And so like, for example, if I was to plug in 1, I'm going to do the rest of them without writing it. But what I usually recommend is do the math by hand, if this was on a test, and show all your work. But I'm running out of energy. So if I plug in 1, that would give me 1 minus 1 is 0. Absolute value of 0 is 0, then minus 2 is -2. If I were to plug in 2, I would get 2 minus 1, 2 minus 1 is 1. 1 minus 2 is negative 1. If I plug in 3, I would get 3 minus 1 is 2, 2 minus 2 is 0. Now, if I was to use some of these other numbers that I chose, negative 1 minus 1 is negative 2. Absolute value of negative 2 is 2. 2 minus 2 is then 0. If I were also, another thing to be careful about with absolute value is you must completely evaluate the inside before you apply the absolute value. And that's just a little thing about the way it works. And there's a reason why, but I'm not going to get into that right now. Now, if I plug in negative 2, that would be negative 2 minus 1 is negative 3. Absolute value of that is 3. 3 minus 2 is 1. If I were to plug in negative 3, negative 4 would be 4. 4 minus 2 is 2. And I'm kind of picking up on a pattern here, which if I plug in negative 4, that should give me 3. Let's just make sure. That would be negative 4 minus 1 is negative 5. Absolute value is 5. 5 minus 2 is 3. And anyways, I have certain points. And kind of like I was saying with the World Series example, if I was to keep going in either direction, I will get more and more points. The more points I have, the better understanding I get. But the better understanding I get of that function. But I'm just getting a little snippet of the correspondence, and I'm trying to get enough to understand the basic nature. And then we can take those data points, graph them on a mathematical Cartesian coordinate system, which will then help us visualize the relationship at hand. So if I actually now graph these points, and remember x is to the left negative 4, up 3, 4y, but basically we're just going to graph them as normal x, y coordinate points, negative 3 comma 2, negative 2 comma 1, negative 1 comma 0, 0 comma negative 1, 1 comma 0, sorry, 1 comma negative 2, 2 comma negative 1, and 3 comma 0. I get some of the points along the absolute value function. And if I were to keep going, what I can kind of glean from this example is that this forms, two different straight lines. From the point to the left, we have a straight line going up this way, and to the right, we're going to have a straight line going up this way. And if you're familiar with what the graph of an absolute value function always looks like, is it always looks like a very sharp V. It's not called a parabola. It's sort of similar, and we're going to review parabolas in a week or two as well. But functions have very specific shapes to them, and those shapes are kind of created by the relationships going on within each particular function. And, we could figure out things like what we refer to as the minimum value and so forth. We're going to talk about a lot of those other features of functions in the next few lecture modules. But for this one last thing I wanted to review are what we call the intercepts of a function, which are basically where the graph of the function run into the x and or y axes. So after graphing a function, we can see, well, this function intercepted the x-axis at 2 points. What we call the x-intercepts. And it intersected the y-axis at 1 point. A function can only ever have one y-intercept. It could also have 0. It can't have more than one, and we'll talk about why shortly. But it could have multiple x-intercepts. It just depends. It doesn't necessarily have to have any, but it depends on the function. And we write those as ordered pairs. So we would have the left point negative 1 comma 0 and 3 comma 0 as our x-intercepts, and 0 comma negative 1 as the y-intercept. And remember that writing a specific point on a Cartesian graph, it looks the same as how we write interval notation, but the meaning is very different. When we're talking about an ordered pair, it's always a specific location on the 2D graph based on how far to the left or right is it and how far up or down is it. Whereas with interval notation in the last video, it was again something entirely. And as I mentioned, math can be very frustrating because the same thing can mean different things depending on the context. So, hopefully it's clear when we're asking, when this means a point versus a interval of numbers. But anyways, that will wrap up this little bit on graphs.